Good afternoon, ladies and gentlemen. Welcome to CIBSE Build to Perform. Welcome to the Headline Theatre, and welcome to today's presentation on Power Distribution Redefined. My apologies if you see me shuffling a little bit of paper. The digital presentation is a little bit more analogue over here. I was expecting perhaps a little laptop in front of me, so I'll just be, if you see me shuffling paper, I'm just trying to keep up with what's on the screen so you don't have to watch the back of my head for the next 30 minutes, okay? So my name's David Williams. I am from Schneider Electric. So I run a marketing team in what we call Power Products. That won't mean anything to anybody who isn't from Schneider Electric. So basically I work in our low voltage electrical distribution business, okay? I've been with the company about 8 years, always been in and around low voltage distribution, and I've also worked in some of the more digital parts of the business around things like building management and SCADA control systems. Okay, so really pleased to be with you today, and for the next, I think we've, did you move that or did I? Okay, there's lots of builds in this, you're going to be a very busy man. Good, so for the next 30 minutes, I'm going to talk to you, so the next 25 minutes, I'm going to talk to you about what we call Power Distribution Redefined, okay? So it's a CPD accredited session, so just in terms of some of the learning objectives, we're really going to focus on, I guess, what we call the mega trends, okay? What's happening in the industry today that is having an impact on the power distribution and the way that we distribute energy, particularly throughout buildings and facilities, okay? We're going to look at the energy transition, having a look at, I guess, how Schneider views the potential move to an all-electric world. Okay, we're going to learn a little bit about the cost of an outage, because I guess that's often the thing that makes people think about monitoring and smart technology. So we're going to have a look at that smart technology element and also touch upon the Schneider Electric EcoStructure sort of methodology. Okay. Okay, so firstly, I guess, who are Schneider Electric? Okay, so hopefully most people in the room will have sort of heard of Schneider Electric or had something to do with Schneider Electric at some point in time, okay? But I guess we have our own view on who we are and what we do, okay? So fundamentally, Schneider Electric is a technology company. That's what we do, okay? We talk about ourselves as specialists in energy management and industrial automation, but fundamentally, we are a tech company. Okay, so at Schneider Electric, we believe that our technologies ensure that life is on everywhere, for everyone and at every moment, okay? So what we really mean by that is that life today is really only on when it's powered and it's digital, yeah? So we all see that in terms of our smart technology, our mobile phones, you know, we always want to be connected, you know, our smart home controls, all of that good stuff. So life really is on when it's powered and connected. But as an organisation, we go a little bit further than that. So really at the core of our business is access to energy. So in a developed world such as this, it's really about making that energy sustainable, reliable, connected and efficient. But at the core of what we do as an organisation, it's about giving access to energy to those 2 billion people in the world who do not have that access today. That's really what we do as an organisation. That's our mission, if you like. Okay, but today, I guess, is a little bit less about access to energy and a little bit more around what is happening in the world of power distribution. So if we look to set the scene a little, we talk in Schneider Electric about the present being digital, okay? So this isn't about the future, this isn't about what's coming, this is absolutely about what is happening in the world now. And some of these things you will be more familiar with than others. So probably the first one, something everybody can relate to, okay? IoT, or the Internet of Things, the interconnectivity of devices to exchange data over the internet. So the first wave of the internet was really all about connecting people. The second wave of the internet that is kind of happening now is all about the connecting of people to those devices, okay? So there are somewhere around 5 billion people connected from an internet point of view. The forecast is there is something between 30 and 50 billion devices connected or being connected. So there is a huge amount of devices connecting to the internet, exchanging data. And the growth of that is absolutely huge. So again, that's your smartphone, your wearable tech, your smart thermostat, your Philips lighting at home, all of that stuff, okay? There is a huge amount of data and devices connected to the internet. Now, some of the other things that are happening you may be less familiar with, okay? So augmented reality, something that we see almost every day, but some people are a little bit less familiar with. I've not seen so much of it at the exhibition this year. There was quite a lot last year. So probably one of the best examples in our space, if anybody's seen it, is the Trimble Microsoft, the HoloLens. So for those who haven't seen it, the sort of smart glasses that allow you to view your BIM models in an AR function on site, so you can see all of your MEP technology within a building, do your clash detection in that sort of AR 3D type space. Fantastic piece of kit for anyone that hasn't seen it. And then artificial intelligence. And I find this one really interesting because we all see this almost every day, but actually it's probably one people think they don't see as much as they do. I think when you talk about AI, people think about robots and supercomputers and all of that good stuff. But actually, I've had an AI interaction today. I would have had a couple yesterday. So the first thing I did this morning after I made my coffee was spoke to Alexa, played a bit of music, checked the weather forecast. Was I going to need my umbrella to come to London? So an AI interaction already today. The other one, I guess probably one of the lowest levels of AI, things like a self-checkout in a supermarket as an example. So the BBC report said there were about 250,000 of these things worldwide about 2 years ago. The forecast in the next 2 years is that will have doubled to 500,000. Okay, so the draw of power, the draw of data, but also the change in the way us as humans interact with each other and also technology. So a huge growth in all of these areas, but this is all happening right now. It's all happening today. So the reason that's important is that if the present is digital, the future has to be electric. Ultimately, something has to power all of that digital technology. So we pose some questions, and these are absolutely questions, topics for discussion, if you like. They're not statements of fact, but they help us start to think about the change in electrical distribution. So we talk about, will IT become the biggest energy demand by 2030? So today it's buildings. It's your typical HVAC type power need. Okay, that's the biggest energy demand. But will that shift to IT? There is due to be a threefold multiplication in IT power needs by 2030. We've already talked about the connectivity of devices to the internet. So fueling this is blockchain, cryptocurrency, all of that good stuff. Your cat videos on YouTube, it's everything. Okay, so if there's a shift and IT becomes the biggest energy demand, the way we manage the energy needs to change. It tends to be more critical, and an outage from an IT point of view tends to be more noticed. Okay. What about solar in terms of renewable fuels becoming cheaper in total than fossil fuels? So this isn't about the renewables in the way we have today, but what about as a homeowner, for example, when storage improves from a cost point of view at the same rate as generation? When will I personally or the rest of us move to sort of microgrid at a residential level? Rooftop solar, some battery storage. Is that a 2030 or sooner or later discussion in terms of where we're going from an electric energy point of view? And then thirdly, a topic quite close to my heart in terms of Schneider Electric is electric vehicles. So, where do we see electric vehicles by 2030? Is that a replacement for half our vehicles, for more, for less? This is a really interesting topic. So transport accounts for about 30% of energy consumption. So even if 25, 50% of vehicles shifted to electric, that would be the biggest paradigm shift we've seen in energy for many, many years. And it comes with lots of complications, but it's really interesting to understand how much electric is needed, the type of electric, and what we need to understand about the world of power distribution. There's a really interesting article probably 12 months ago on the BBC entitled "Have You Bought Your Last Car?" And it really brought a lot of these topics together. So it talked about, particularly if you lived in a city, actually, would you need to buy another vehicle ever again? So if you think about an electric vehicle, that takes out the cost, probably the cost of fuel, certainly the cost of some of the maintenance around a combustion engine and all of that good stuff. Actually, if the electric for the vehicle was potentially renewable, it was potentially a little bit cheaper. And then what about things like artificial intelligence and a driverless vehicle? Actually, if you think about the cost of a taxi journey, if you take out something like the driver, then the fuel, then some of the maintenance, is it more efficient to work on a pence per mile basis in an autonomous electric vehicle than for me to buy a car if I live in a major city? It's some really interesting discussion that brings it together, all of these topics, and makes us think about, I guess, the world we live in and the way that world is changing. So, if we stick with the theme of the future being electric, what does that mean for us? What are some of the things that need to happen? The first thing is we believe that the electricity sort of mix in terms of energy, it will need to double. Now, this is a really interesting topical discussion at the moment. Berkeley, a state in California in the USA, announced a couple of months ago that they were going to ban natural gas hookups into residential buildings. So they have said that all new residential buildings now have to be all electric. So electric boiler, electric cooking, all of that good stuff. They are the first in the US, they certainly won't be the last, and there's lots of discussion around that in the UK today. So we start to see that as the move to an all-electric world, effectively. Absolutely, in terms of the way that energy is generated, we believe it will become more decentralised. So we believe that about 40% of electricity will be from renewable generation globally by 2040. So we're already pretty much at that in the UK today. The stats tell us from an electricity point of view, we're already at about 40%. And we believe that 70% of what's added will be renewable. I guess the shift there is not so much the fact that it is from renewables, but it's really how that renewable energy generation is managed in terms of the decentralisation of the grid. I talked a little bit earlier about, from a home point of view, solar panels, battery storage, etc., etc. So it's very much becoming decentralised, sort of mini microgrid type situation. And then, of course, the final piece is if the world's become all electric, if it's become very, very reliant or fully reliant on electrical energy, then 100% uptime is fundamentally important. You cannot have this reliance on electricity and not have a stable system, particularly from a supply side, but also very much from a demand side, and that's the kind of area we're going to focus on today. So what we started to talk about, I think, is a bit of a transformation. Okay, a huge shift in digital and also in power distribution. Now, those two things actually go hand in hand, and they're shifting in the same direction, sort of at the same time, really. So we at Schneider talk about two faces of the same coin, really. So what you see on the screen is how that shift is moving. So you have today, everything is centralised for scale. So you have cloud computing, and you have really a sort of mains generation, single, big power plants grid, okay? Very centralised for scale. Where we're going is that more decentralised model for a couple of things, for autonomy and absolutely for, particularly on the data side, to manage that critical reliability closer and at site. So from an energy side, we're talking about microgrids. Effectively, as we decentralise for renewables, we're taking more of a microgrid approach. So in both power and digital, we move from centralised for scale to decentralised for more autonomy and greater control of criticality. So the world is changing. I think there is no doubt in terms of the things we've talked about in the last 10 minutes that the world is changing. I think we all see that all around us. We're having a discussion at home. I've got my little boy's 6. We're having a conversation this week about will he ever buy a combustion engine vehicle. He'll probably go straight to all electric, certainly by the time he can afford a car. Actually, in terms of the technology that he's used to, in terms of all of the connected tools that he's got, even at that age, I think we see a fundamental shift in the world today. So the electrical system must change. So what does that mean for us? I guess we've already talked about the uptime. We've already talked about the decentralisation. Often one of the barriers that we get to discuss at Schneider is around skills and appetite. So here what's really interesting is the top statistic in the middle. Okay, so this is from I think it's from a LinkedIn article. So it talks about by 2025, we believe that around 75% of the workforce will be of a digital, what they call a digital native or the digital generation, okay? So this is anybody who is a millennial or younger, okay? So if you think about what that means for people's expectations in terms of the way they work, even a very late millennial is from that Facebook generation. You know, even right at the end of the millennial spectrum, you know, you were on a mobile phone at school, you probably had a laptop when you were at university, you were absolutely on Facebook. This is where you've lived your life. You are of that digital generation. So in terms of the way that engineers manage power distribution, this is now how people expect the world to operate. Apps, real-time information, everything at your fingertips, you know, a user interface that's very clean, easy to play with. This digital generation will probably have as bigger impact on LV distribution as some of the mega trends around the shift from centralisation and the shift around the way that energy is being used. So there's a big cultural shift in terms of the way we expect to interact, I guess, in the workplace and in our chosen field. So there's lots of things happening. How important is it? Okay, so we've talked about a lot of megatrends, a lot of nice big words, a lot of themes, but in reality, how important is that to us in the world? Well, the answer on the screen is very important, okay? So our industry absolutely needs to sort of close the gap, it needs to change, it needs to be aware of these things. So we've picked up a couple of examples. So December 2017, an electrical fire at Atlanta Airport. Atlanta was the world's busiest airport at the time. In December 2017. It caused an 11-hour outage of the airport. It grounded over 1,000 flights and it cost 40 million in terms of lost revenue, you know, lawsuits, all the other good stuff that goes around it, okay? So I would imagine the cost of putting some preventative technology in that building, in that facility, across that campus, was a very small percentage of that 40 million, okay? But the cost is enormous in terms of the outage. 11 hours, it's a fairly long time. I guess in the world of electricity, it is a long time. But 40 million, I mean, it's a huge, huge cost. The other interesting statistic, and when I started to read up on this, I found this one quite interesting, that the single biggest cause of data center downtime is actually power. Okay, so 33% of all data center downtime is caused by power. Now, I was expecting it actually to be something around the network, around network issues, but that relates to about 30%, just under 30%. So the biggest impact is the powertrain and when you have a power outage. And then I guess looking away from the sort of demand side, a little bit more on supply side, earlier this year, so this was June 2019, there was a grid outage across 5 countries in South America that left nearly 50 million people without electricity. I mean, that is a huge impact. So I guess what this says to us is when we don't get it right, you know, it causes a big impact. Not on the screen, but my favourite analogy is for anyone that's a sports fan, an NFL fan, the 2013 Super Bowl at the Mercedes-Benz Stadium, the fairly new Mercedes-Benz Stadium. If anyone remembers the game, the lights went out at half-time during a half-time show. Okay, it was a 34-minute outage. Actually, the issue wasn't that big. The challenge was the time came from they couldn't identify where the fault was. So a lot of engineers running around a very busy stadium, 34-minute power outage, 34 minutes with no floodlights. When 108 million people are watching the game, the reputational impact alone is absolutely enormous. So just think about that because we're going to talk about stadiums a little bit later. Okay, so we absolutely need to be conscious of these things and I guess design our electrical architecture in a way that can mitigate some of these impacts. So if we move away from the mega trends and bring that down a little bit to a more of a technical level, more of a design level, maybe some things you can take away from today, we're going to pick on, I guess, a fairly standard example. Okay, so we've picked a coffee factory. This could really be any building. The reason we've picked the coffee factory is this could be a sort of small and medium building up to, I guess, you know, a huge factory for a multinational organisation could be considered critical. The philosophy ultimately is the same. Okay, so before we talk about the electrical distribution, I'll just set the scene. You know, standard building, some things are critical. So think about probably process and packaging and probably things like accounts where they're processing orders. Some things a little bit more general. You know, your meeting rooms, your general office space, your cafe, etc. So real mixed use, but quite a typical building. Facility manager's got quite a nice office in our diagram because he's quite important, but actually it could be off-site, managed, but a real mix, I guess, of loads and of bits and pieces, okay? So the electrical network is the backbone. Okay, we've already talked about Schneider Electric believes that life is on when it's powered and it's digital, and to be digital you need power. Ultimately, power is the basis of everything. I like to remind my colleagues that work in the building management area of our business that actually, without power, all of their fancy BMS just wouldn't be a reality. Power really is at the heart of everything. So if we think about what a typical electrical network would look like, okay, so it's always been the backbone of operations, and it usually operates in a fairly standard sort of waterfall type model. So you would have a main sort of LV board fed from the utilities down in the switch room. Then you would have some secondary distribution feeding, say, the critical loads and also feeding the floors, and water falling down to your final distribution to feed loads, lighting, elevators, all of that good stuff. Okay, so a very standard and I appreciate quite simplified electrical architecture, standard sort of waterfall. So in yesterday's system, let's say 10, 15 years ago, the electrical ecosystem was fairly simple. So single source, fossil fuel, hydroelectric, doesn't really matter, single source of utility, external utility supply. But it was also supplying fairly simple loads. We talk about simple heating, lighting, and simple process, and this bit's quite important. So 15, 20 years ago, there's probably a lot less automation machinery in the floor of that factory, a lot more manual process. So single supply, simple, feeding simple loads. And in terms of the requirements, they were the traditional straightforward requirements of protection against faults, continuity of supply, and then your classical calculation of cascading and discrimination to avoid any faults, or be able to isolate faults. Okay, so a very simple standard electrical network design. So this has changed a huge amount in that time period. So we see a little bit more today that equation has absolutely evolved, and it's evolved into something different. So the first thing we see, and we talked about this a little bit, is that distributed generation, okay? So what you'll see even in our coffee plant, for the eagle-eyed viewers at the top there, you'll see some solar panels. So not only do we have multiple sources of energy, but some of that is coming from the consumer. So the consumer is now generating some of that demand. So you have utility supply, you have renewable supply on site, you can have multiple types of utilities, so very different in terms of the generation. What you'll also notice is that list of loads has increased, and it's increased a lot from what we had on the previous slide. So we're looking at automatic HVAC, presence-based lighting, variable speed, security, access control, condition-based monitoring, and particularly, you see at the bottom there, a lot more digital. A lot more servers in the building, a lot more software. They're probably using SAP or Oracle. They've got a HR system, some sort of convoluted holiday booking system. We all have one of those in our business. There is a lot more loads and a lot more complex loads being fed now by the electrical system. So what does that mean? Well, it absolutely doesn't mean that you don't need the things on the previous slide. Okay, so you absolutely need your protection against faults. You absolutely need your discrimination, and your cascading and everything to be correct. You need the basics, but you also need to consider changes in legislation. You need to absolutely consider efficiency, the carbon footprint, the sustainability message. You're now using more. It's very clear now you're using more. You're feeding a lot more loads, but how do you reduce the impact of using more? And also the cost. I mean, this is clearly a business. How do you reduce the cost? And also the connectivity piece, the data security, the cyber. All of that is now very important. So, what does the new electrical system look like? What should it look like? Well, one of the things we talk about is measurement and control at every level of the system. So think back to earlier when we were talking about data. Devices that are connected, I can have a conversation with Alexa, she can tell me what the weather is like. Think about that connectivity piece. This is really about information. So what you'll probably find is at the primary LV distribution, at the main switchboard, this is all around crisis recovery. So think about this now as a large coffee factory. Think about the Super Bowl analogy around finding out where your fault is. We're talking about crisis recovery. So either preventative in terms of pre-alarms, think about some of the asset optimization. Maybe it's breaker monitoring, breaker status, maybe it's about trip unit usage. So it could be preventative. Or it also could be about that network management, in case of a fault, how to quickly identify, quickly isolate, and quickly rectify. So at this level, it's all about quick and reliable crisis recovery. From a secondary switchboard point of view, it's more around load management. Again, you're alarming, perhaps some remote operation. We talk about things here like benchmarking, okay? So billing may be a little bit less important. Benchmarking, absolutely. Where are your hotspots? You know, where is your load too high? Again, think about that data to act upon. And then at the final distribution level, we're starting to talk a lot about real-time monitoring. Again, I talked about the digital generation. This is absolutely the expectation. I can see what's happening now, where it's happening, and I can see that quite easily. So think about load failure indication, think about your typical kilowatt hour usage, all of that good stuff. But it's always real-time at this level now. So what this gives us, I guess, is what we're moving to is that sort of Alexa, tell me about my power distribution network. That, you know, that is the model that we are aiming to move towards. The other thing just worth saying, because people always ask this question about, this is very nice in the new building, but actually a lot of the buildings that we are going to operate exist today. Okay, about 80% of what will be in use in 2050 exists today. A lot of this can be done in an existing building. There is now a lot of wireless technology in this space, so that is absolutely, you know, it's not just for new buildings. There's also a cost piece here, because that's the other question we get asked a lot. What is the cost? Okay, so we're going to come back to cost because we've got a sort of real life working example, and I'll talk you through, you know, the additional cost, and I think you might be surprised. So if we think about our coffee factory, how do you achieve that? So at Schneider Electric, we have I guess a philosophy called EcoStructure. So this is our IoT enabled reference design for buildings, and it looks quite complicated, I guess, if you've not dealt with EcoStructure before. The critical thing here are the numbers, okay? There's a 4, a 6, and a 3, and it becomes quite easy to remember and to understand. So at the top there, you see the 4. So there are 4 end-user environments in which EcoStructure has been designed, because we appreciate that those 4 are fairly different, okay? So you have buildings, data centres, industry, and what we call infrastructure. So that's really grid. Then you have 3, so connected products, edge control, and apps, analytics, and services. And that's your innovation at every level. So your connected products are the things that you probably know Schneider Electric for predominantly: connected breakers, meters, variable speed drives, switchboards, etc., etc. At the edge control layer, that's really your operational software. It could be building management, could be managing your low voltage distribution, could be SCADA control, metering and monitoring. And then at the top level, that's really about remote analytics, what we call advanced decision-making support. So how do you take all of this data from level 1 and level 2 and turn it into some sort of actionable insight? And that area, I think, is becoming a bigger challenge for people today. The more data you have, the cleverer you have to be at the top level. What do you do with that data? And then finally, we have 6. There are 6 reference architectures, but they're interoperable and seamlessly integrated. So if I lived in the end user space of a building, you know, I'd be interested in the reference design for building and for power. So one is a little bit more sort of BMS control focused, and one obviously is a little bit more distribution and power control focused. And I might take both of those architectures, and it would give me, if we flick back a slide, you know, the sort of monitoring and understanding of my coffee factory, if that's where I worked. Okay, so we just also, I touched on cost. So just give you a little example of, I guess, a real life EcoStructure example. Okay, so not a million miles from here, the new Tottenham Hotspur Stadium has all of this EcoStructure technology installed. So you'll see smart LVMV switchgear, smart panels, lots of edge control technology, also remote operation, and then some apps and analytics technology that is allowing them to adjust and change the stadium as they get used to using it to reduce, not only reduce costs and also increase satisfaction. So from a smart LV point of view, the focus here is on power distribution. The cost to go smart was around 1%, less than 1% of the cost of the wider power distribution. So the cost when you put it in is minimal. It really is minimal. And when you think about the Super Bowl example, the reason I use the Super Bowl is because you have another stadia here who actually has the NFL games as well from a UK point of view. So the cost of going smart, of getting all the monitoring at a hardware layer is around 1%, less than 1%. And we talk about the cost impact when 100 million people watch a game and the lights go out. You know, it suddenly becomes a less of a cost discussion and more around understanding the impact and why you need some of this technology, and absolutely why you need all of that data around your power network and your power system. And then just to close, so finally, just to give you some more examples of where this sort of reference type architecture is being used in the world. So we see this EcoStructure system being used in 3 of the 4 top hyperscale cloud providers. The really interesting one for me is over 1 million buildings worldwide. 3 of the top 5 hotel chains and about 40% of the world's hospitals are all working on some sort of EcoStructure platform, enabling this type of monitoring, be it in power distribution, buildings or industrial automation. So this really is a model it's benefiting certainly critical buildings today, but absolutely we see moving down into the wider sort of small and medium buildings and facilities space.